Local area networks, or LANs, can vary widely in size. A LAN may consist of 2 devices in a home office or several hundred devices in an office environment. When you connect 3 or more devices together, you need a dedicated network device to enable communication between the individual devices. In this topic, we'll cover 3 different types of network devices used to connect hosts: hubs, bridges, and layer 2 switches. A hub is a multi-port repeater that takes an electronic signal that's been received from a device on one of the ports. It magnifies that signal and retransmits it out to all the other ports except for the original incoming port. All the ports on the hub fall under a single collision domain and a single broadcast domain, and it works at the physical layer of the OSI model. A collision domain, which is common in early versions of Ethernet, is a section of a network that's connected by a shared medium where data packets sent from one device will be heard by all the other devices on the segment. A network collision occurs when more than one device attempts to send a packet on the network segment at the same time. To avoid the collision, devices in the Ethernet segment participate in the Carrier Sense Multiple Access with Collision Detection, or CSMA-CD. This method uses a carrier sensing scheme in which a transmitting data station detects other signals on the wire, and they won't send their frame if someone else is using the wire. As the number of devices starts to increase in the hub-based environment, the problem gets much worse. Many collisions and retransmissions can happen, which can lead to excessive LAN traffic congestion. 2 types of devices that can be used to reduce the number of collisions in the network are bridges and switches, which are commonly used instead of hubs. Bridges were the predecessor to switches, and bridges typically had a very small number of interfaces, while switches can scale up to several hundred interfaces. Today, it's common to use switches as network devices operating at the link layer of the TCP/IP protocol suite to divide a network into segments and reduce the number of devices that compete for bandwidth. Each new segment then results in a new collision domain. More bandwidth is available to the devices on the segment, and collisions in one collision domain don't interfere with the working of the other segments. Bridges and switches learn which ports lead to which host MAC addresses by monitoring the source MAC addresses in the Ethernet headers on frames that arrive on their switch ports. The port to MAC address mappings are stored in the MAC address tables, and for each incoming frame, the destination MAC address in the frame header is compared to the list of addresses in the MAC table and is forwarded out the ports that lead to the destination MAC address.